Good afternoon, everybody. I hope you can hear me well. So, as Florian was saying, indeed, we are new to the party. Although we've been working with OAI since more than 3 years now, we joined the Alliance, recently. And what can I say? Thank you, first of all, for inviting us for the talk today. We didn't expect that fast, and to the talks we've seen yesterday, I hope in a couple of years we'll be here with products based on OAI as well. So that said, a bit about us. We are based in Romania with about 65 engineers, software engineers working on mainly SATCOM projects, distributed around the custom projects, custom development projects, defense projects, and our own products, which is the topic of today. And the title of the presentation is "It was a journey getting here." So our journey. Phase one, we had the opportunity of working on a satellite backhauling optimization project back in 2019, I think, where we reached an improvement of 2 to 4 times the performance of the satellite backhaul option for a cellular network on ground. And at that time, we got our first enabler. We met our first enabler on the journey, which was the European Space Agency and the Romanian Space Agency behind, that supported us and encouraged us to go forward with it and get it as a service. On the journey, getting the optimization of a satellite backhauling solution for a cellular network was not that lucrative, as all of the MNOs actually that we were discussing with were not interested because of the need of the satellite link, where it was the last case scenario and not the first one. So because of the lack of interest, what we realized is that with the coming of the D17 NTN, we could actually be a contributor to the development of NTN going forward. And that was phase 2 for us, the publishing and then the actions we took. So what we did was to go back to ESA, put up a plan in place where we said we want to pivot from backhauling towards direct-to-device. And this was back in 2021. Reach a level where we can prototype activities on NTN with the goal of having terrestrial to non-terrestrial handover. So that was basically the pitch that we had put in place back then. And the long term was phase 3, go towards onboard processing. So basically decoupling the 5G network, doing flying software. Where we are today. So today we have one project that is running, that is building the testbed that I was mentioning earlier, with 2 components. One is a multi-orbit satellite channel emulator that we ended up developing ourselves. As in building the elements, buying a channel emulator was more expensive than building one for us. And more so the fact that you had limited access to the an off-the-shelf channel emulator compared to one that is built by ourselves. As Thomas was saying earlier, the opportunities of developing a 5G NTN network are bigger if you have the control throughout the testbed, the network. And in that sense, our channel emulator is a pure software-based channel emulator, so PC-hosted software, using SDRs as conversion from RF to digital, and that's about it. All the rest is controlled and developed by us. Then the second pain point was identifying the virtual 5G network, as definitely it was not an option to build one from scratch, and it was not an option to buy one either. So then we were looking at options on open source communities, and this is the enabler number 2 for us. As doing the research, we had seen the work that OAI was doing. Definitely it was something that made sense to what we wanted to do, and we started looking into it and decided to go with OAI. Again, this was back in 2021. Again, essentially the goal for us was to do TN to NTN handovers, and in that sense, What we decided to go towards is see what's lacking compared to what is now available in NTN. And as Florian and Thomas were saying earlier, NTN is a bit behind compared to terrestrial 5G OAI, and there is a lot of work to be done. And on the other hand, we wanted to keep as close as possible to ORAN because of the standardization on the long term, again, onboard processing and going towards a decoupled 5G network. And there are a number of modules that we had put in focus in development. First thing was to get it running, and now, I mean, it's close to a year now. We have, and as you'll see after the presentations, we have a testbed that is able to do GEO and LEO 5G NTN calls through our channel emulator. I will not go into the high-level architecture as we have the demo after, and you can get to see it and ask all the relevant questions. The thing I want to point out here is the approach we took, the philosophy we took as one major component for us is the orchestrator, so the shared access module that we want to implement in the sense that keeping it as software-based as possible, we want to maximize the hardware capabilities. And here, SDRs are not necessarily used at maximum capacity, depending on the use case. And in that case, you can spawn several instances that you need and share the hardware resource across one SDR. That's the logic behind. And that's the thing that would be a big differentiator, as a prototyping testbed for companies. Okay, our achievements. First of all, the channel emulator. As I was saying, we developed it in-house. It became into a product. It launched this year. It became a sort of a Swiss knife at the end of the day because it started as a replica, getting all the functionalities of a traditional channel emulator that's on the market. We started adding things because we saw several use cases that were coming from people we were discussing. And here I'm referring to things like we implemented Diffie and SIGMF. We added the Diffie generator as an option, so we can generate Diffie traffic through the channel emulator. You can use the channel emulator as a Diffie converter. You can use the channel emulator as a digital spectrum analyzer because, again, it's software. Behind it, once you have the data in digital, you can do a lot of stuff with it. So it became a product, and that's one achievement we had. The other is, as I was mentioning, to have a functional testbed that is able to do a call over GEO and LEO with the current implementation that is available not on the main branch, but will be available on the main branch. And you will see it today running. The third one is, as Thomas was mentioning, we started contributing to the OAI code base with the SIP19 implementation on GEO. And we plan to, and are working on, so it's not a plan, it's a work in progress. We are working on in getting our testbed in the main branch of the NTN code base in OAI. And then Diffie implementation, we are also a member of the Diffie consortium. Our implementation is certified through the Diffie Plugfest and so on. This is something that we see as an achievement as well. There are a number of things to come. Again, the work to be done is significant. On the other hand, what we've seen throughout the past 2-3 years is that the plan that we put in place is usually changing according to the use cases and what is required actually from potential users, not what we want to do as a black box. I believe this is the roadmap we had gone to ESA and ROSA, the Romanian Space Agency, back in 2021, saying that, okay, phase 1 is over, we are not able to do business with satellite backhauling, we want to go towards direct-to-device. We were going through the, I don't have a light here, phase 2 basically was the assessment, as I was mentioning earlier, where we decided to go with OAI and use SDRs as off-the-shelf hardware, and from there on it's the story that it would have been difficult to plan, to be honest. It's not easy to say, yeah, we'll get this done in 2 years. And not as the last thing, definitely I want to thank the shout-out that everybody was mentioning to OAI, the European Space Agency, and also Thomas and the team from Fraunhofer IIS, as they've been guiding us, on the learning curve along the way. So, thank you.
Thank you for the presentation. One question I do have is, I mean, you mentioned 2025. You would like to launch a satellite, or you would like to use a real satellite. So, I mean, are you part of European projects for that, or are you looking for some partners?
So again, this was the roadmap that we had gone to ESA with a long shot, big dream, because there was supporting us. Frank, as Florian was saying, was our mentor behind, and he was saying, okay, in the long term, this was 2021. Consider even having, as Fraunhofer was mentioning just now, having your own prototype satellite. Put it on the roadmap, because you'll never know. And that's how it got there. Definitely now we are not looking in raising our own satellite, but looking for partners to do that. And we are in talks with several SNOs that are interested in joining, the effort once we have the running testbed in lab, so the lab satellite.
Okay, clear. Thanks a lot.
Thank you.
Yeah, just one quick question. So what can we see at the demo?
So the SIP19 functionality will be demonstrated today. That is the attachment of a mobile to a 5G NTN network of a satellite. Unfortunately, as was mentioned, it's not the LEO implementation, because SIP19 is not ready for LEO, but for the GEO code. LEO would have been working just as well, but SIP19 is the big new thing, at least for us and for the industry. Okay. There's no known implementation for now.
All right. So looking forward to seeing that. Thank you once again.
Thank you.